Part 1 of Experiment 19 is to investigate the corrosion of iron. So if you're looking at Experiment 19, it shows the setup of test tubes. So here we have just an iron nail that has been sandpapered. And then in the next tube, we have an iron nail that is piercing a piece of metal, of zinc metal. In the third test tube, which I'm going to pull out here, we have an iron nail that is piercing a piece of copper. And in the fourth test tube, we have an iron nail that has a piece of copper on it. And then around the top of the iron nail, there is copper wire wrapped around. And then that is wrapped around a piece of zinc. So those are the 4 test tubes for this lab. The corrosion of iron is a slow process. So in order to observe what's happening in a short amount of time, we're going to go ahead and use some color indicators in auger to see what is being oxidized and what is being reduced. So in this next clip, we're going to go ahead and look at the preparation of auger and the indicators that we are going to use. Okay, so I'm making the auger solution to pour over the nails. So I have my water boiling, and then I'm going to add auger. So it's kind of like Jell-O. If you probably use it in bio, but it's going to get hard. And I don't want to add it all at once. I need it all to dissolve. So I got to do it in 4 portions. So I'm going to do a little bit, and I'm going to stir it. And then I'm going to do it again 3 other times and keep stirring until it dissolves. And then we'll see what happens next. Okay, so I've added the auger in 4 portions so it'll all dissolve. Okay, I'm going to actually turn down the heat here. Alright, so I did that. So there we go. We add our ½ gram of sodium chloride. I need all that to dissolve, but that should dissolve pretty easily. And then I'm going to add this potassium ferrocyanide, and this is going to be our color indicator to see if iron is being oxidized. Okay, it will form a complex with iron that's been oxidized, and it'll turn blue. So that's the red stuff actually right here that I'm adding. Okay, I'm actually thinking we're just going to turn this off here. Okay, so now actually we have this yellow. And then I need a color indicator to see when oxygen is being reduced, because that's really key. Oxygen being reduced is part of what happens in the corrosion process. So I'm actually going to be adding phenolphthalein, because that will turn pink if we reduce oxygen to OH minus, because we should know in a basic solution, right, phenolphtalein is pink. So I need 15 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's about 15, and I'm going to stir that up. All right, so now I want this to cool a little bit before I'm going to pour it into my nails. All right, those nails that I prepared from before. So that's all dissolved. I just want to cool it a bit, and then I'll be pouring it in the nails, and I'll show you that process. Okay, so this is cooled a bit. All right, so I'm gonna go ahead and pour it into the test tubes carefully. I want to cover all of the nails with this, except the one that's just the plain nail. Okay, so I'm pouring this all the way over this system, each system here. Okay, and I don't want to disturb these for a few minutes. All right, I can actually already see colors developing, but I don't want to move anything because then stuff will kind of get messed up, because I need to get it needs to be like Jell-O. It needs to harden, and then once it hardens, I'm going to pick them up and I'm going to show you what we see, and I'll take pictures, and we'll look at all the pictures and see what's going on here. So we're waiting for some colors to develop. Okay, so I've let these nails sit here for a little while, and it's like Jell-O, the auger. This one has been set in the least, but if we look here, this doesn't move anymore. It's like Jell-O. So they're pretty set. So looking at this one, this is just the plain nail, and I don't know if you can see, I'm going to post pictures as well, but there is blue, there we go, blue at the bottom right on that nail, and look where we see the pink, right at the surface. So we're going to have to remember what is going on, what those color indicators mean. Pink means oxygen was reduced. Blue means iron was oxidized. Okay, so that should help you figure out what those reactions are. All right, tube number 2 was with the zinc. Okay, so here's tube number 2. So all I see is pink on the nail. So there's pink all over the nail. I'm looking, I don't see any blue. All right, so we've got that zinc metal there. We see a bunch of pink. Pink means oxygen was reduced. There's no blue, so no iron oxidized. Well, remember, oxidation and reduction go together, so what was oxidized in this case? Tube number 3, copper with the metal. All right, I see blue. Let's see if we can focus in. There's blue on the nail, above and below the copper. And what is the copper? The copper is completely pink. All right, so oxygen was reduced. Iron was oxidized. So remember, the copper is not reduced. Pink means oxygen is reduced. It's being reduced on the copper. The copper is the inactive cathode. It's providing the site of the reduction. Finally, here's our last tube, and I have my iron metal. I'm looking around. I don't see any blue. I just see pink, and the pink is kind of all over. It's really around the copper because there's copper wire here, so it's really around the copper, but there's no blue. All right, so pink means oxygen was reduced. Copper's not reduced, oxygen's reduced. It's being reduced on the copper. Copper is the inactive cathode. Cathode and anodes are metals. What was oxidized? Nothing? Well, iron wasn't oxidized. Well, there's other metals in here. Copper's in here, zinc's in here. Based on other observations, you should be able to figure out what is oxidized in that case. All right, so you're gonna need to figure out what's oxidized, what's reduced. I gave, it's all based on those colors. And go ahead and you'll write your half reactions for those oxidation and reduction that's going on.